Okay, and welcome to another exciting image processing class. Today, I think we're supposed to be handing in our midterms. How exciting. How did you do?
Tell me.
I didn't look at it yet. Did it work?
I got an output image.
You got an image?
Yeah.
Does it look like anything?
Yeah. It looks like a knee.
It looks like a knee?
Yeah.
Yeah?
Yeah.
Getting it works?
I'm not 100% sure if it's a leading algorithm.
How many colors did you get?
I let you put in how many colors you wanted.
Okay.
Yeah.
But at the end of the day, did it give you exactly that many colors?
Yeah.
Oh, it did?
Yeah.
Oh, and how many colors did you get?
Not the amount that I wanted.
How many? Was it less than 255?
Yeah.
That's okay.
I had to decrease. You know how like you have that size
Yeah.
threshold thing?
Mm-hmm.
I had to decrease that to get. I decreased it all the way to 10, and I got 248 colors. But I realized that wasn't.
That's okay. 248 colors is like a good.
So I didn't leave
Yeah.
it like that though. I
Okay.
just left it with. There's like 100 and something colors.
172 colors.
100 and something.
Somebody else submitted a result, which I will play for you here, and it is, I think, the most. I guess it's done in the spirit of a true median cut algorithm, and it's even object-oriented, which I kind of liked. Although I must caution you against going overboard with object orientation, because in the world of image processing, it can be really slow. But having said that, it can also look very elegant and be cool looking. So I kind of like that. It's cool versus really slow. So here's these are another 34 dicomed images. These are scans of my knee with the torn meniscus. And so here it is after an equalization. Here it is after a median cut algorithm. That looks pretty clean. And here it is prior to the median cut algorithm. And it's kind of hard to tell, but what you'd want to do is you'd want to see the before and after of the histogram equalization. So this is, showing you a bunch of noise. And that noise is something which you can remove. And, I think there are a few different interesting and wonderful algorithms that we can use for noise removal. But having said that, I really liked what happened here. So I looked at, this is a Niels code now, and you can see negative numbers, right? And what do you suppose those negative numbers represent? They're colors, right? How can you have negative color? Any ideas? I asked him this, and when he told me, I said, it's obvious. It's a byte. It's a signed byte. So it goes minus 128 to plus 127. So once you know that, then you say, oh yes, of course, if you print them out, they're going to look negative, because 2's complement, So I thought, okay, that's fine. And he's certainly got his image looking good. And at the end of the day, I said there was a limit on 255 colors, or 256 colors, however you want to call it. 0 to 255, I guess it is, so that's 256 colors. And then he says, okay, well, we did this quantization, and now he's done, and the number of unique colors is 243, reduced from 2,468 on this particular image. So I thought that was pretty cool. So that had a very good dynamic range, and he was able to do a color reduction on that. So then I asked this basic question after the histogram equalization, and I see all the noise there. I say, how would I reduce the noise in this image? Any ideas?
Characterize the noise first, right?
You could do, but there's something else going on here, right? It's a tomographic sequence, which means it slices. And one slice is very close to the next slice. Only difference is going to be exactly where the slice is done, but also the noise will have changed randomly as you go from one image to the other. So what can we do when the noise is relatively random as you go from one image to the other? You could compare it, or you could average it. right? In other words, if I had a reasonable signal on one image and it's pretty close to the reasonable signal on the next image, then all I really need to do is average the two, and the backgrounds will tend to cancel. And so as a result, while you may have a little blurring that occurs between the two images, we could certainly make a compelling argument, I think, that the averaging between the two 16-bit images will reduce the noise substantially. I think. Now, would it make sense to do that with image sequences that come out in 8? Should we quantize to 8 bits and then do the noise reduction? Or should we do the noise reduction with 16 bits? Does it matter? It matters?
Will there be less noise compared to 8 bits?
Yeah, if you're doing it with 16 bits, you're going to be doing your image processing with something that already has a higher dynamic range. So that's not a bad idea. If you do it with 8 bits, you'll still be able to do some noise reduction, in theory, but it won't be as good. Right? So then the question becomes, how would I do the averaging in the 16-bit image sequence? Or better yet, how would I even display this image sequence? Could I display the image sequence? Would it make sense to display the image sequence? How about if we convert it? Let's try a mental experiment. Suppose I said I have a clever way to take a 16-bit image and make an 8-bit image. Now let's suppose I have a clever way to take the 8-bit image and save it to the disk. So now suppose I have a bunch of images. In fact, I do. When I look at the data, and I believe it's in a folder that's labeled data, images, is it DICOM images? I forget now. Or maybe it's under C:. Oh, I'm in the D drive. Silly me. Data, images, DICOM, right? So what do we got? Here's an image sequence. Okay. It's an image sequence that I don't have any Windows programs that can read. Right? Windows programs don't know about DICOM images. What kind of images do Windows programs know about? JPEG. JPEG. So what would it take to convert this image sequence into a folder full of JPEG images so that we could view them quickly using standard built-in Windows tools, which there might be Paint programs or whatever. What do they have in Windows? Paint, right? Other things too, I think. So what could we do for that?
We already know how to open them, right?
We can open them. Can we save them? Do we know how to save them?
You can create an image from your short processor and resave them.
Yeah, and save them. Sure, why not? So suppose we do something like that. Suppose we start off by saying, let's create a list of input images for us to sort of muck about with. That should be something that we should be able to do with relative ease. So what I'll do here is, I think I'm working in arrays. Let's start with what would be a good way to do this? I guess we'll start with files. I'm in the files directory, and what I want to do is make a file list. So let's do that. Let's make a new Java class and call it list files. This will be my little example for listing all the files in a directory. And what we'll do, just for the sake of argument, is let's start with the basic question of how do I create a list of files in a directory. I think that's a fair question, and you should be able to deal with that. So what I'll do is I'll start off with dir, dir, list, dir list, and I'll call it DL equals new dir list, and its arguments are a file directory with a suffix, or a start directory and a file filter, or a start directory and a file filter and a progress bar. Suppose I want to do this with the full Monty, the start directory, the file filter, and the progress bar. What would I do for an input here? How would I get a start directory? Let's do it this way. Start directory, file filter, progress bar is true, and what we'll do is, how do I get a start directory? I spelled it wrong. There. Start directory is a file type, file start directory equals, I guess he wants alt enter, file IO. So what do I type here? Do what now? File path. I could probably make a new instance of a file. I could do feudal.get read directory and ask it for a dir. Select dir. Select a folder. That's what we call a directory nowadays. We call it a folder, right? And then what's a file filter? File filter. Let's see. File filter. FF equals new file filter. Okay. And what do I have to do? Type alt enter here. What should I be doing? Alt enter. Java IO file filter. Sounds fair. And now he says, what do I have to do here? Implement the methods. Okay. A file filter needs an accept method. And so what that's going to do is, let's make this FF for file filter. There. So the question now becomes, how do we know when we're going to accept the file? A file filter can accept an input file based on a fully qualified path name by looking at the structure of the file. For example, if it ends with .jpeg, we could accept it and only accept JPEG files. Or we could say, let's accept JPEG files and GIF files, or JPEG files, GIF files, and PNG files, or JPEG files, TIFF files, PNG files, or we could just accept all files. Right? So I'm going to be, I'll say, unselective in my filter. So the file filter, in this case, accepts everything. And it accepts it because it says, I don't care what the file is, I'll just return true. Now apparently what happens during this dir list process is it interrogates the file filter to determine if the file is acceptable. And so what we're going to do in this particular case is just say, yeah, we accept everything. But if we didn't want to accept everything, we wouldn't have to. And in fact, if you wanted to do something that only processed, let's say, Java code, you could make it so that it ends with .java, and that's it. And that's equivalent, to saying, let's make something, let's say, more selective. So you could say anything that ends with .java and was created within the last 2 weeks. You could put in a time frame in there, so when the file comes in, you could check to see when it was modified, or check to see when it was created, or check to see if it has any text in it. You could be as aggressive in your filter as you like. What would this be an example of? Since we don't know the implementation. Here's the hint. Since the implementation could take any one of many shapes. Since the implementation shapes, many shapes. Polymorphism. Yes, thank you. Thank you. I guess that was subtle. Many shapes. So this is right, because you could have any one of a number of different implementations for the file filter. All you have to do is provide an implementation for the accept method. And then it has to return true or false. It's also an example of inversion of control, because some framework for listing files is going to keep calling the accept method in the file filter. And so we rely upon it to invoke us. And so we don't know very much about the framework, but we do know we have to tell it whether or not we're going to accept the file. So it's an example of polymorphism. I would have also accepted inversion of control. Oh boy, what a tough crowd. And there's only 3 of you. Jeez. How you doing there already? Not so good, huh? Looking forward to your spring break? Nah. Okay. Okay. I have my spring break all planned out. I'll be grading your midterm. What I do for spring break is paperwork. So now what we'll do is we'll get the files, and it says here I can just get a great big array of files, or I can get the directories but not the files, or I can get the files and not the directories. I like that. So what's going to return is anything that isn't a directory, and it's all going to come back to me. And so now I've got these files, and it's going to be a big list of files, and it's a file array. And I really don't know what's coming back, so I think it would be swell if I could print it. So let's do that. Let's print utils.print of file array. Alt-Enter. And now I think maybe you're ready to try this. It should give us a nice list of files. And if it is images you're looking for, we might as well navigate to the DICOM image directory. Hey, Arodi, how was your midterm? Not so terrible? Really? Did you get an image?
No.
No? Oh, I don't want to hear that. What happened?
Oh, it's just the way I was trying to like traverse my what do you call it? My histogram. Well, it just wasn't working. I didn't do it right. I'm trying to figure out.
Bummer.
Yeah.
Did you submit something?
No.
No? Oh, dude.
I mean, just me what I have. It's not working. That's basically the problem.
You got to submit something. You can't just not submit your midterm. It's like required and everything.
Yeah.
So let's do an open over here. And look at that. I got a bunch of stuff. And it looks like images. Look at this, a nice big array of images. Huh? Now, as I go through the sequence of images and process them, I am engaging in an activity which we in the biz call image sequence processing. Dun, 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 dun. Oh, so now I've got these images, right? And we were going to proceed to do something with them. We have to do something with them. What can I do with these images? It says here I've got this thing here for reading in DICOM images from a file. And at the end of the day, it can take the file and display it. It can make pixels out of it. It can median cut the file. It can make a short image bean out of the file. And at the end of the day, I get an image from the file. And that's an AWT image. So what I'd like to do is make that into one little tiny static invoke from anywhere method that is going to take an image, read it in from the file, do a median cut, and then return it to me, and not do any of the in-between stuff like display it. I just want sort of a utility for reading in DICOM images, cutting them down to 8-bit images, and then giving me an instance of a java.awt.image instance. And once I got that, I feel like I have something useful and reusable. So I'll extract that to a single method. This is Anil's code now. Well, I don't know if I should send you Anil's code. You have your own code for doing your median cut. This does a median cut using Anil's algorithm, which may not be particularly efficient, but I don't care because it works, and I'm cool with that. And so now let's see if there's anything in here I need to comment out, such as displaying an image. I don't need that. And so it's in the DICOM median cut.java. I'm just going to keep calling getImage, and it's going to get me some images, I suppose. So let's try that out. I've got my little list files doodad. I think would be fun, wouldn't it be fun, if we had a for loop. For integer I equals 0, while I is less than fa.length, that is for all the files in the image, I++, and then what I'm going to do is I'm going to call image img equals Alt Enter. This thing just bugs me sometimes. DICOM median cut dot. Did I forget to declare this public? I wanted getImage, but it's not giving it to me, so I'm thinking it's not public, and that's probably because, yes, it's private. So we'll make it public so that getImage will work. And then what we'll do is we'll pass in fa of I, and that will let me go through each one of the images in sequence, and the only thing he's bitching to me about now is that I have to throw an exception, and I will do that in the main method signature. And now I got all my images, and I'm going to display them all one at a time on the screen for you right here. Image utils.display image, and I'll put in the image img, and I guess I should put in the image number just for a good time. Quote, do we need a fully qualified path name? How about just the name? fa of I dot get name. And then I'll hit Alt Enter, and then I put in the parenthesis and the little doodad semicolon, and that's it. So this now prints all of the all the files. I don't care about that. Instead, what I'd like it to do is display all the images in the directory for me to look at. All the DICOM images will be median cut quantized and then displayed for me to look at in their beauteousness. And then we shall behold my knee. Oh, I have to select a directory. Wow, that was pretty slick, actually. Wasn't that slick?
Yeah, I can't do that. I don't have the methods like he has.
You don't have a way to get an image from the directory after median cut quantization? Because what I did was I didn't have it either, but I made it. Let's see if we can just run through how I did it. What I really want to do is be able to call getImage, where getImage, and I'll actually write a little Java doc for this because it just seems so genuinely useful. Use, I know, input a DICOM 16-bit image, perform a median cut requantization to 8 bits and return the image in java.awt.image format. Okay. F is a file for the input image, and the return is a java.awt.image instance. And now if you go to Control Q, you can actually see it's been formatted nicely in JavaDoc. So that enables you to automatically create HTML from your code if you maintain your JavaDoc appropriately. Yeah, a JavaDoc will output HTML, or you can even output MIF for FrameMaker or RTF for Word. And that's done using a JavaDoc Java program called a doclet. Doclets allow you to take JavaDoc and transform them into a variety of different word processor formats. There might even be one for TeX or LaTeX. There should be one for LaTeX. In general, you can find those things under Tools. Here, Generate JavaDoc. And what this will do, it'll take the whole project. It'll do anything protected, or it won't generate the private, which is good because you don't have to maintain the documentation on the private stuff. But you can have it generate the use, the author, the version. You can put in other command line options and generate the heap. And then you can create your own output directory. And this whole thing that it creates, you can be transformed into a zip file that makes references to a whole bunch of images that actually make it look nice. And then you can take the whole thing and put it up on your web page and publish your API. And then you could offer it for sale. You could monetize all of your Java efforts, just as I have done, because people just send me the big bucks. It just comes rolling in. Plus, when you go to parties, all the women will throw themselves at you because of your famous API. They'll say, "What do you do?" I say, I'm a .com entrepreneur. .com entrepreneur. And then everybody says, "Oh, that means unemployed." Which is essentially the same thing. So, unless, of course, you're a successful .com entrepreneur. Even then, they might interpret it to mean you're unemployed. I am reminded of the story, which may be true, about Sergey, who started this company called Google, and he called up his mom and he said, "Mom, I'm a billionaire. We went public." And she said, "Oh yeah? And when are you going to get your PhD?" Mr. Smart Guy. So I don't know if that's true or not, but there it is. So I have isolated Anil's code for enabling me to get an image using the median cut algorithm. I proceeded to, you can see where he just calls median cut down here. I then proceeded to list all the files and then display the images. So now the question is, what can I do other than display these images? And the answer is, well, of course I could save them. And the way I would do that is I would look at image utils, and I'd see if there was a save as, and there is, and I can save this as a GIF. All I need is a file. So here's the image, IMG. What should I use for the file? Any ideas? I mean, I can go to F of I Oh no, it's a file array. File array of I. I could get the directory, or I could get the parent. Hey, that's a good one. Let's get the parent. Get the parent. What would the parent be? Any ideas?
The directory of I.
Yeah, the parent directory. So then if I have the parent directory, then what do I do?
Probably want to append the file name.
Yeah, I would think so. But just not to put too fine a point on it, in case you're wondering what that does, let's do the following. S out, Control J, Enter. We'll print the parent file just so you can see it. FA of I dot get parent file. And then we'll just print out all the parent files and see what they look like. They should all be the same. They should all be the containing directory. Presumably, if it's DICOM, it should just print out. It says too much output to process. Really? I think it's printing too much. It's a very noisy program. You know what I think I've done is I've invoked Anil's code, and it has its own print statements in here. Yeah. Why don't we comment some of this print stuff out? Any other print stuff in here you see? I'm going a little fast. Oh, there's tons. Any other print stuff? He's got a lot of debugging statements. Let's run that again.
Can you go back to your the image get image method?
Yeah. This is too much junk. I wish I had a way to get rid of some of the print statements though. Find system.out. Oh, here's more. I really don't know where the other print statements are located. So you want the get image method. That's right here. I can take.
No, the actual implementation.
You want the implementation of the get image method?
Yeah.
That's right here. He's using this thing here called the DICOM decoder, which is looking like it's got a bunch of print statements in it. Let's see if there's any more. Is that sort of what you guys had as well? The DICOM decoder? How did you guys decode? That's how you do it, right? DICOM decoder? I wish I could turn off some of it keeps saying too much output to process. So what I'll have to do prior to getting the image is I'll just print out the information about the list of files. So let's just do that and forget about getting the image. Hey Brian, how's that midterm treating you?
I submitted it.
You submitted it?
Yeah.
Did you finish?
Yeah.
Everything works?
Yeah.
Cool, cool. That's good. So here's what happens when you print out the list of directories. That get parent file returns just what you expected it to return. It goes to the file, it figures out the name of the directory that contains that file, and then it prints it out, which is just what we wanted. Now, if I was going to take these files and I was going to translate them into JPEG or GIF or some other format, what would we do? How would we do it? We could either do it manually, right? So here I'll try this manually because I think that's just as good as anything. I want to give them a directory in which to live. Where are the DICOM images? Alright, why don't we take all of these images and turn them into GIF. What does GIF stand for? No idea?
I know what it is.
Make dir GIF. It's a graphic interchange format. So GIF is very good for 8-bit images. Whether they have 256 colors or 256 gray levels, it's excellent for that. GIF, it does not distort the images if they start with 256 gray levels. GIF will distort the image if it starts with 16 million colors because you've got to reduce it to 256 colors. That's actually something Median Cut is very good at. So here it is. We're going to make a whole bunch of GIF images and put them in the GIF directory. I thought it might be fun for us to start by formulating the new file names based on the old file names, only with a GIF suffix. So what we'll do is we'll say new file. Here's the parent file, comma, quote, GIF. I think you need a dot in there too to make it a legitimate GIF image. And put in a little parenthesis. Now let's print it again. Only this time what will happen is it'll print the directory, and it'll print the directory and then .gif, but not the proper file name. So let's see if that works. Okay, so what I really wanted to do was put the GIF in here, and then plus, actually let's look at it the way it is. I just want to see what it looks like, because I think I saw a slash in all of this. For some reason the compilation's taking a while, but let's just do that. Open. So that's looking like a decent directory in which to save things. Let's make a little auxiliary variable here. New file, introduce a variable, extract variable, what shall we call it? GIF. That's good. Call it GIF. So now it says something like directory / GIF, and now what I'd like to do is make a file equal to new file of gif.toString comma fa of I dot get name plus quote dot GIF, end quote, end paren sem. So we'll just print it and see what kind of file we're looking at here. If the file name looks good, then we can actually try and run this with the files. It'll create files for us. So from our list of input images, we would like to create a list of files for our output. Hit open, and that represents the input image with a .gif suffix into a directory that has a GIF title associated with it. So what I'm thinking is, I can convert the image from DICOM to java.awt.image format using the median cut algorithm, and then what I can do using my new found output file is call imageutils.saveasgif, take the image and give it an output file, and Bob's your uncle. That's the whole thing. So what did I do? I very carefully made sure that before I started writing output files, I knew exactly where they were going to go. I knew exactly what they were going to look like. I had a correct suffix. I had a correct placement and correct name for each one of the files, because I don't want to overwrite or destroy existing data. That's so important, right? Because if you start writing files out and you put them willy-nilly anywhere you want, that's bad, and bad things will happen. So I'm trying to be, I guess, methodical or careful or whatever you want to call it. This is one of those you have to be careful things. Because if you're doing image sequence processing and you're outputting files, you can be outputting a lot of files. Right? Here I'm working with this real toy example. It's just a small image sequence with only 34 files. But remember, once you start doing image sequence processing with video, it's 30 files per second or 60 files per second. And if you start writing out 60 files per second and you got a few minutes, like 5 minutes later, that's, I don't know, 300 or 600 frames, depending on your frame rate. So this, this could be bad news for your hard drive. So let's give this a whirl. I should probably have a little print statement at the end that says done, because it can take a while to do image sequence processing. So we'll start here. Open, and it's looking like it's working. You can kind of see it looks like it's done. This is too much output to process. What's up with that? It's been doing that lately. I think it's done. I think it has the look and feel of doneness. So what have I done? What did I do? I don't know. There should be like some images out here somewheres, right? DICOM, GIF. Oh, look! DICOM images converted to GIF. How come they don't show? Is there a way to get a preview on these things? Do I have to double click on them? Well, that worked. Apparently the browser knows how to decode it. But you can open it with anything you like, I think. What's preview do for me? Well, that has the look and feel of workingness. I'm not sure why the images aren't in any particular sequence. Is it... I want to make it run by itself. But it's not cooperating. What's this do? Oh. Nothing? So you can go forward and backward. What's that do? Huh. So that's beginning to look kind of like, I don't know, biomedical imaging. right? Because it's an image, and it's a biomedical image, and that's what makes it biomedical imaging. So there. So what can we do with all of this wondrousness? Huh? I've got 34 images, and they're sitting here in 34 files. Does that sound like a good idea?
To have files.
Well, if you have an image sequence of one thing, and you would like to manipulate it, why would you take the image sequence and break it up into all these different images? Why not take the image sequence and put it into one file? Wouldn't that make sense? Yes, sir.
I think that makes sense if you wanted to do some processing with it.
Sure. Or even if you wanted to disseminate it.
Then it makes sense if you wanted to work with it, then you have to break it down to its individual components anyway.
Oh, all right. You could make a compelling argument that having individual images is a very convenient thing, but I could also make an equally compelling argument that if you wanted to disseminate the image sequence that is my knee, for whatever reason, you could do it with a single file instead of 34 files. How would you do that? How indeed. How indeed. Well, save as GIF seems to be a very popular thing. What about this idea about saving as GIFs? Here it says it can write a GIF. Oh, that's very exciting. What kind of GIFs can it write? I wonder. It says write GIF is part of a J2D IO GIF stills. J2D, let's take a look. J2D IO GIF animation. Ooh, animation. GIF animation. What's a GIF animation? Yes, sir.
GIF with multiple images.
Excellent. That's exactly what it is. It's an image sequence stored inside of a single GIF file. It's characterized by the fact that each of the images has only 256 colors, and they all have the same 256 colors. In other words, if the colors have been created using a lookup table, they all share the same lookup table. Moreover, the GIF is compressed, but it's compressed with an algorithm which is lossless. What's a lossless algorithm? Okay, Brian?
Sounds like an optimized algorithm, something that can't be any more efficient.
A lossless algorithm is an algorithm which enables an exact reconstruction. So, for example, when you create a zip file with all of your executables, it's compressed with a lossless algorithm because you can unzip it and your executable files will still run. That's very nice. If your executable files didn't run after that, it would suck. Like big time. So, lossless algorithms are with us always. gzip has them, 7-zip has them, zip has them. They're using code words that capture repeated binary strings or patterns. So it sees repetitive patterns, creates a code word, and then distributes the code book so that you can reconstruct the exact image or exact exe file. But then there are these other kinds of algorithms which we call lossy algorithms. For example, JPEG. JPEG uses a lossy algorithm. What that means is that the image that goes in is not exactly the same as the image that comes out, but it looks good. So it's good enough. And it's a lot smaller. So what kind of compression can I get with a, let's say, Lempel-Zev zip algorithm? That's a lossless algorithm. The answer is maybe about 50%. And what kind of compression can I get with JPEG algorithm? Well, it depends is the proper answer, but could be 60 to 1. Big time. Instead of 2 to 1, 60 to 1. Big time. Big time compression. But it's lossy. You dare not use it for an exe file because it will never execute again. You can't reconstruct the original file exactly. So, when you are working with an image that's already 8 bits, already been stepped on with your median cut algorithm, it's perfectly acceptable to use a lossless algorithm like GIF, and even make a GIF animation out of it, because you have an exact reconstruction of the image, no loss. So GIF animation is perfectly well suited for 8-bit medical images. Perfectly well suited. So then comes the next obvious question. How do you make an image sequence from a sequence of GIF images? That is, how do you make a, I'll call it, GIF animation from a sequence of GIF images? And the answer is you use a format called GIF89. GIF89 actually refers to 1989. It's the days of yore, the old days. Well, it turns out the Lempel-Zev-Welsh algorithm upon which the GIF89 encoder is based was encumbered by a patent. The patent was held by Unisys, and for the longest time nobody could save any GIF images without violating the Unisys patent. So I used to have a global variable that said we are legal, and you had to set it equal to true. And if you did that, then I could distribute the code to you and make it work. Otherwise, I'd have to say, sorry, you have to agree to the licensing rules that Unisys has, because it was a license violation. Nowadays, the patent has expired. The algorithm is in the public domain, and so we can distribute this code without any license payments. So here's a right animated GIF. Takes an array of images. You can describe whether or not it's looping. You can describe how many frames per second, and you can describe an output stream. And you can use the GIF89 encoder. Right animated GIF. If you go to GIF89 encoder and hit Control Q, you get all of the documentation. And you even get the sample. Pretty cool, right? It all comes out because it's been properly formatted in Java doc format. So what this says to me as a Java programmer is, if I call GIF89 encoder write animated GIF, I can pass in an image sequence, which is nothing more than an array of images, and define the other parameters, including the output stream, and it should save the whole thing for me as an image sequence, which is kind of nice. Now, next question. Okay, who can decode an GIF animation? What applications can decode GIF animation? Any ideas? The answer is all modern browsers. Internet Explorer, Firefox, Chrome, Safari, you name a browser other than some text-based browser, and it'll decode it and it'll show the image sequence. Very efficient way to disseminate image sequences on the web. All you have to do is take the image sequence, throw it up on a web page. You don't need no stinking HTML5 for this. You don't need a plugin. You don't need Java. You don't need nothing. It decodes it natively. And it's been doing it for decades. Over 20 years now. 89, 99, 2009, 10, 11, 12, 13, 14. Wow. 2.5 decades it's been doing this. All the browsers know how to decode GIF animations. All of them. I use them all the time. Here's an example. If you go to, that's probably a GIF animation, but I wouldn't know for sure. If you go to Google and you just type in GIF animation, oh wow, there's like a whole web page on this. So here's a GIF animation. It's a cow. Here's a guy playing guitar. Here's animals. These are all GIF animations. Most of them are pretty stupid. Bunch of stupid GIF animations. But the nice thing about it is you can make your own, and they don't have to be stupid. I really don't know what this caterpillar is supposed to represent, but I think it has something to do with getting high. I'm thinking you could just stare at that all day long and wallow in your crapulence. So there it is, GIF animations. So let's go to the GIF89 encoder, see if we can write out our GIF. I was in list files at the time. Instead of calling save as GIF, I've got my lovely little images. I'm thinking I can make an image sequence out of them. But before I do that, I really want to just sort of GIF89 encoder dot, right? Alt, enter. It says main. What's that do for me? I just want to see what this main has in it. I thought he had a nice example where he was going to write a whole sequence of GIFs. Didn't he give that to me? Maybe I have to cut and paste it. Write GIF animation. How's that? I'll do that. Oh, he's not going to let me do that? Really? Mouse right. Oh, you can't cut and paste out of the Java doc. Oh, that sucks. Alright, so what do I have to do? I have to call add frame, set comments, set loop count, set uniform delay. That's a lot to remember. I think I want to copy this or something. Oh, here we go. Here, I'll copy this. Very good. Copy. Am I copying the right thing here? Darn it. I lost the, this is what I want. I want to copy this. Mouse right, copy. I hate this trackpad. Drives me nuts. Okay. Let's go in here and paste. And I'll get rid of this nonsense with the stars. There we go. So now let's take this GIF89 thingy. I only need one instance of it, so I'll put it right above the for loop. Let's see. I'm going to make a whole series of images in this for loop. So what I need to do is get rid of these files, get rid of the save as, because I don't want to do individual images anymore. Instead, what I'll do is I'll go to the GIF encoder, and I think I can add a frame, and the frame is an IMG. There we go. That's now that's making sense. What shall we do for annotation? GIF encoder dot set comments, and I guess DICOM or something. Really doesn't need comments, and it does need to be correctly spelled. Oh, you know what? That has to happen at the end, after you've added all the frames. Set loop count. COUNT. And I guess that's going to be a 1, so it'll loop. And for some reason it's unhappy with the fact that I uppercased, but that's okay. We'll fix that. What else do I need to do? Set the number of frames per second. Set uniform delay. It's giving me a hard time because I spelt it wrong again. And now that has to be int math.round of 100 over pick a number. 5 frames per second. That's pretty good. And now what else? GIF encode. Now I need an output stream. GIF enc.output stream encode OS. And now next question, how do you make a new output stream? So I guess we're going to need a file output stream. Futil futil dot get write file, select GIF output nparen nsem, and now we need a file output, so file FO for file out, and we'll make a file output stream, file output stream FOS equals new file output stream. We'll put in the file out, out. It's giving me a hard time. So now I'm going to take the file output stream, pass it into the encoder, and then when I'm done I have to close it, fos.close, and all the rest I can delete. And that is how you do that. Done. Done deal. So now a basic question, will it work? Oh, and when you're done, I think you have to probably print something. Sout, Control-J, Enter, quote, done. There, final touches. So this should take an image sequence of DICOM images, median cut, reduce them to 256 colors or less, and then save them to a single output file whose name is something or other. I need a name. How about calling it all.gif? Save. I guess that's it. Oh, all.gif has nothing in it. That's bad. Maybe I forgot to flush my my output stream before I closed it. fos.close. That should flush. Maybe I need to flush twice. It's a long way to the kitchen. Flush. I'm thinking that should have been enough to create the output stream. And as far as I know, that's all you need to do to save your file. But I'm going to try a flush anyways. Because it never did print done, you know.
Yeah, I just gave that little error and said too much activity.
Yeah. Wait, there's an error here. Index out of bounds. That's not good. He's trying to read a DICOM image and he's getting an index out of bounds exception at runtime. Oh, here he's trying to decode all.gif. But he shouldn't try and decode that. I'm not sure why he's trying to decode it. Something's going on here. Let's display the image as we go. There's a blemish in my demo. Gee, that never happens. Okay. Open. I want to save as all.gif. Save. It says DICOM reader get info, and he's having this hard time here. So what I would do, because I'm not exactly sure what's going on, is I would surround this with a try-catch block and allow it to continue. And then encode the whole thing when I'm done, because that's my way to hack around it. Surround with try-catch. We'll print a stack trace, but then we'll proceed and save the image anyways. I know that's not a clean way to deal with it, but there's something going on here I don't quite understand, and it may be it's trying to decode one of those images that's not supposed to be able to, or just seems like it can't. Open, save as all.gif, save. Now why couldn't it try and catch that exception? That's a good question. Don't know the answer to that question. It may be the case that my GIF encoder is what's giving me the hard time. If that's the case, then I need a different GIF encoder. And if I have to go through the process again with a different GIF encoder, it should be after the break. So what I would say is, let's take a break, and I'll quickly modify my little GIF encoder. Yes, sir?
Is it because your Git directory is inside your DICOM directory and you got all the files inside and it's loading them?
You think it's loading all those files too?
It seems like it's trying to load them.
Well, I know it does. It shouldn't try. Let's do an experiment. Let's print out FG. No. I mean, it's obviously trying to display the images, and it's succeeding. And it's succeeding. So why it would give me a hard time on that, I do not know. One thing I could do, I know what to do. How about we start by creating an array of images? And then we go through each one of the images, and instead of displaying them, we just do the conversion. IA of I equals IMG. How's that? So then we'll know, we don't need a try-catch block anymore. Then we'll know that we've got all the images. Right? And we should be able to, when we're done, say something like S out, Control J, enter, got, quote, got, end quote, plus IA.length plus, quote, space, images. How's that? So now we'll know that we've read in all the images. And we can leave off the business about outputting an encoded sequence later. So let's read them all into an image sequence. And we'll call it an image sequence array. That's fair. Oh, he's still giving me a hard time. Yeah, look at this. He's trying to decode all.gif. So I think you're right. I think he's done something here which I wasn't anticipating at all. He's recursively listed all the files in that directory. And if that's the case, that is exactly what he shouldn't be doing. Let's print out FA of I. Oh yeah. He found 69 files. Well, there's no way he's going to be able to decode these GIF images. So you're absolutely right, Rich. He's explored recursively the entire list of files, and we need a non-recursive mechanism for getting that list. Dirlister is apparently not suitable for listing directories. What would be a good way to do this? It says get files, not directories. Dir lister apparently does recursion. I forgot. So dir lister's no good for us. If you go to start directory and you say get, oh, I know, maybe it's list files. How's that? Maybe that'll give us only a non-recursive list. I was too fancy when getting the dir lister because it recursively lists all of the files in the directory plus its subdirectories. That's what you want. 35 images. Perfect. Although it got something here, it says GIF. So it didn't just get the files. It got the files plus a. We need a new file filter here. Or unless there's another way to list files and not directories. Now, you know what you do is you go through it and you say is directory or is file. So you put in a new file filter and you say list files and you put in a new file filter. And the new file filter is going to have to put in an accept method. And then it'll say return path name dot is file. And that'll eliminate all the directories. If is file will return true if it's a file. If it's a directory, it will return false. So then when you go to list, it should eliminate the GIF listing in your list of files. Wow! How educational. So now we have 34 things with files and no directories, which is perfect. What do you think of that? Pretty good, right? Now I can do the encoder properly. And now the encoder can work with an array of files. So we'll get a file output stream. We'll make a new instance of an encoder. We'll run a for loop. We'll go to the GIF encoder. We'll add the frame. It's IA, image array of I, right? Then we'll proceed to set up the comments. Set the loop count, so it'll continuously loop. Encode the output. Flush the output stream. Close the output stream. Print out done. Bob's your uncle. And that's it. So now I can hit open. The output file will be all.gif. Hit save. And it threw out a null pointer. Well, that's fun. And now it's break time. Because it looks like I've made another mistake somewhere and I just got to sit here and have a little quality time with my code. But that happens. But that was a good call, Rich.